we are going back to our studio, and I left it the same way as it was, not exactly because I restarted the program, but I think it's better to start everything from scratch. So if you haven't saved your R script from last time, you can save it by just simply Command S or Control S, or just File and Save. And then if it's saved, it's also up in the Google Drive. So what I'm writing is always up in the Google Drive. So you will always find it there. Download, open with R, and you will have the same things in your R that I have or had. So I just close them and I open a completely new R script. You can also clean up your environment if you click on this broom. Yes. And also clean up your plots if you have. Yeah, you haven't got any plots, but you can also clean up them here, or you can also clean up your terminal here with the same kind of way. Okay, so today we will go through some very basic functions. We will discuss how you can learn how to use functions. And also we will write some very simple functions, because if you write functions, it's much easier to understand how they work. So one of the most common and most often used function is actually the C command. So let's go through some very basic R commands. So if you say C, and then you will give a few numbers, then the C is actually, if you go to the help and look for what is C, why is my, okay, caps lock. So it's basically just combining values into vectors or list. That's one of those functions which you will use the most often. But it's already a function. It shouldn't be like combine or concat or something like that. But because we are using this very often, and I will tell you why we are using it very often in R. It was simplified to C. Of course, if you run it like this, it will just print it out, will be printed out to the console. But if you want to put it into an array or a vector, like vector 1, then we are again using this left arrow. You will also see today what's the difference between the arrow and the equal sign. If we are in this context, there is nothing. It is exactly the same. So if you say Command Enter in any of those, it is exactly the same. In both cases, first the right-hand side is evaluated, and the value which is coming back from the right-hand side will be assigned to the left-hand side. This is happening. It's a bit more obvious with the arrow, because what you do here will be pumped in to what you have on the left-hand side. So what is exactly this this value, this output? Let me show you another very common and very simple command, which is the sqrt, and let's say it's sqrt4, which is the square root function. So this is how you can quickly calculate the square root of any number, which is, of course, the square root of 4 is 2. So number 1 will be, let's see, and we'll just open the comments or the chat. Okay, so Chioma, I think maybe your focus is not on your terminal or in your environment. I mean, the environment is this one here. You shouldn't write anything there. Oh, again, okay, I know. So if you are hit enter, then it will make a new line. If you hit command enter, it will be executed. I think that's the problem. That's something you have to get used to. But if you are using R a lot, you will be a bit more practiced or confident. And is it the problem? So if you hit command and enter together, is it working, Chioma? I hope so. Okay. Or the green arrow. The green arrow, so we have, as we discussed before, we have two green arrows actually. So one is for running the whole script you have here, but you don't always have to run the whole script. Or just run from that line where you are. So if you are here and push run, then it will be only, this will be executed. If you run this one, this whole run, then the whole thing will be, I think, executed, or maybe not. Anyway, the command enter is also a shortcut for doing this. So one of the reasons, okay, let's go to, first of all, let's go to the sqrt. I have to put this command window, this chat window somewhere else. So if you are going to the help tab and go for sqrt, it's always good to learn how to read these help pages. So for each function, you will give arguments. This is what is going into the brackets. Sometimes it's only one. Sometimes it can be a numerous arguments, a lot of arguments for more complicated functions. So this is actually your input to the function. And then the function will give you back a value. So if you think about the function, it's like a black box. You put in something, there is something happening inside, and then it will give you back what you want, which is the square root, or as you can see here on this help page, the other very common function is ABS, which is the absolute value of any argument you give. And because R is a vector-based programming language, we have another thing which is extremely useful in R. I think this is working in R and maybe in MATLAB and maybe in Julia, but it's not working in many other programming languages. If you have an sqrt function, it will be good for calculate the square root of a number, of one number. But because R is a vector-based programming language, you can give a vector as an argument for almost all of the functions, but definitely for square root. And it will calculate the square root of all of the values in the vector and give you back a vector with the same length with all the square root values. So if we modify our vector one to 4, 9, and 16, let me just put it down here, command enter. So now vector 1 here is 4, 9, and 16, and then I say that vector 2 should be the square root of vector 1. So as you see here, I don't give one value, but I'm giving 3 values at the same time. And if you look here on your environment, the numbers are okay, or if you just simply say vector 2 here on your console, and you will see that from all numbers, the square roots are calculated. This will help you a lot later when you try to do something on a lot of numbers, when you are writing your own function and you are going through sequences and searching for a sequence pattern or anything like that, or calculating average values or standard deviations. If we are speaking about average or arithmetic mean, luckily we have a function. I think it is a base function. Yeah, if you see base here in the help, that means that it is a part of the base R programming language. If anything else is here, then it's not the R, but it's one of the packages, which usually you will have quite a lot of packages. I already have quite a lot. But mean is actually a basic function, and it is what it says. So it calculates the average or the mean from numbers you are giving to it. So for example, if we want to calculate the mean, the average of these three numbers, I can just simply use it here in the terminal. I will put it here. And as you can see, it's 9.666 something. I don't know if you remember, but in the last, in our first R introduction meeting, we put in new values into a vector. So as you see now, vector 1 is a vector with 3 elements, which means that if you want to extract the second element, you say vector square brackets 2, vector 1, sorry, because that's the name of our variable, and it will be our second element in the vector. If you want to give a new value, and this is what I will do here, I'm saying that vector 4 should be 25. And again, it's vector 1. So from now, vector 1, as you can see here in an environment, has the number 4, 9, 16, and 25. But I can also do something which we did before. We can say vector 7 should be 81. Oh! Sorry, it's vector 1. Okay, so what you see now in the environment, that you have 4 nice values in the beginning of your vector, then 2 NAs, and then 81. So the problem with calculating averages, that what you have to do is that you have to sum up the numbers in your package, in your array, in your list, and then divide by the number of elements in your list. It can happen that, I mean, even if you do some kind of experiment and for certain parameters you weren't able to calculate, you weren't able to observe a result, then you cannot really write in 0. 0 can be an observation. 0 is, you know, is like an inhibition zone millimeter value can be. I hope I said it right. But if you cannot observe it because someone just threw out that plate you were measuring the inhibition, or something happened with the bacteria and it didn't grow up, then you will have nothing in that cell of your Excel table. So when you are calculating the mean, you cannot just simply say, okay, I had 10 isolates, and I'm always calculating the average from that 10. I'm summing up the numbers of these 10, and I'm dividing by 10 always, because there will be gaps, there will be holes in your list, in your data. So the built-in function of R can handle this. So if you go down again to the help window, you can see that X is always an obligatory argument which contains the numbers, what you want to calculate the average of. But there is another optional argument which is na.rm, which is in default, and this is what you can see here, in default it's false. So if you have NAs in your vector, it will not remove them. The na.rm means that remove NA values. So if I'm running this mean vector1 again, it will give me a quite strange result, because there are some NAs in my vector. It cannot really calculate the average. But if I'm saying that, that calculate the average of vector 1, and if you find any NA values and remove them, then we will have a normal number, and 27, which is probably the real average of these numbers. You can also calculate averages or means by just simply doing what you would do in mathematics. So you can use the sum function, which is, again, if you look at here, it just sums up the values in your vector. So we are summing up, and then we are dividing by the length of our vector 1. If I'm running this again, I will get back NA, because we have these NA values there constantly. But as you can see here in the help window, sum also has this na.rm optional argument, which is again in default false, but we can make it true. So you can remove these values. And of course, now here we have a problem. So we removed the NA values from the sum, but we didn't remove the NA values from the vector when we calculated the length of the vector. So this number will be the real sum of those numbers which are not NAs, but this will be 7, because the array is 7 element long. So let's see if the length has any na.rm. No, there isn't. So this is not a good method to calculate average in a vector with gaps in it. So let's do our own function to calculate the average, and then you will see what is happening inside a function. What we will do is we will say function, which means that we are now defining a function. Let's call it myMean. And first, let's just say that it will get x, which will be a vector. Again, I'm using the curly brackets, which will define the scope of the function, which will define the inside this black box. So the black box will get x. X will be a vector, for example, vector 1. So let's start with, okay, of course we have the main function. I won't put it inside because that's cheating. Let's put this here. Of course, we don't calculate vector 1, but we will calculate the things on x. So x will be only visible for the function. You will see this later when we will run the function and we will call the function. X is only visible inside. There is no x outside. And this is very important, and I will speak about this a bit later. And it's also very important to give back what we calculated. So let's just put the results. I know that this won't work. So we will work on this function because it's not working with NAs. So let's put this into y and let's return y. Now I think it's in brackets. So if we have a vector, let's go back to this one. So I will rerun this line with Command Enter. So our vector 1 is now again containing just simple numbers, not weird NAs. And I am highlighting this whole function and say run here or Command Enter. No, it's not working like this. Sorry, I quite rarely write any functions in R. So give me a second. Okay, I know what's the problem. It has to be written a bit differently. So it will be something like this. Yeah. So now we can run it and we will have our function here. And now if I say my mean and I give vector 1 as the argument, then it will calculate the mean. So what happened here? And also, if you want to look for x, let's try to put x. X is not an object. Y, there is no x and no y. So I don't see the values of x, which is here, or y, which is here, because it's only visible within the scope of the function. This is very useful, very helpful as well, because you won't fill up your environment with a lot of variables. They are only visible within the function. So what is happening? So that's happening here, the same way as we called mean or the square root or any other, or sum or length. We are calling a function and we are giving a variable, what we defined here, up here, vector 1 as the argument. Within the function, it will, the whole array or vector we gave will be put into variable x. But again, as I said, variable x is only visible inside. And then, of course, we are summing x and then dividing by the length of x, and then we are returning y. Why this return is important? Because this is what comes out from the function. If you don't return anything back, then you did the function for nothing. There are sometimes functions which are, for example, there for initiating special functions within a program. So you won't see that the function was executed or called. But in most of the time, you are calling a function because you want to do something with the variable you give to the function. We will do a lot of plots later. Every plot is a function. So what you want to do, you give your data frame, you give your data points, x and y, axis values to a plot, and the plot will give you back a nice picture. So that's why we have the return here. Return will give back that value, what we want to calculate with the function, which is in this case, the average of these numbers in vector 1. Of course, our own hyperfunction or superfunction is not working with these kind of vectors yet. So if I'm putting back element 4, element 7, and again, my vector looks like this, 4, 9, 16, 25, NA, 81. If I'm calling my mean on vector 1 now, it will give us the 19.28, which we already know it's not a good, it's not the real average of that 5 number which is present. It is the sum of the 5 numbers divided by 7. So we have to modify our function to handle NA values. I think there is already an NA dot remove. Let's try to find this out. Okay, there are some not really nice ways to do it. So we will, instead of doing the built-in functions or built-in ways to do this, we will make a for loop, and we will make an if statement inside. Okay, so the first thing what we do is we will define an empty array, which is, again, I will define this empty array inside my function, so it won't be visible outside. So let's call it tmp. And this is an empty vector. We already had loops last time, so you will need loops. It's always good to repeat and repeat loops. What they do, they are repeating things as well. So what I will do, I have the x variable, which is a list of numbers. I have tmp vector variable, which is empty, and I will put the numbers from 1 by 1 from x to tmp vector if they are numbers. If they are not numbers, if they are NAs, I won't put it into C. So what I will do, I will go for E in X. So we are going through all the values in X. And if, let's hope this one will work, E, I think there is an is numeric, is dot numeric. And it's like this. I will tell you what I'm doing. Then So what I'm doing is I'm going through all the numbers, all the elements within vector, within that x, what we get as the vector. If it is numeric, then I will put that element into TMP vector, the append command. I hope it works like this. Yes, it works like this. So as you can see, again, it's a function which will get x and then values as arguments. So x is the vector where the values to be put into, and the values are the values which will be put in. So I'm putting I, which is always the next element of vector x, into TMP vector. Just to make it a bit more visible, we will use the print command as well. So we will print I here. To see if only numbers will be put in. And we will also print here. There are nicer versions to do this, and then I will sum up. We won't need this because we already removed the NAs. So I will sum up the values in TMP vector, and I will divide by the length of my TMP vector, and I will give back Y. Let's hope it will work. I'm highlighting it and pushed Command Enter. And now I am trying with this one. So what happened? Okay, it's not working. NA is also a number. So what we have to do here, I think, is NA. Something like this. Let me just try. Yes. Okay. So this is a bit more complicated now. Is NA is a function which checks if the argument you give it is an NA or not. So it's exactly what it says, is NA or not. So it will be true if you give it an NA. Let me just show you here. Is.NA hello is false. Is.NA 300, it is false. Is.NA NA is true. So every time the I is an NA value, which means that it will be the fifth and sixth element of our vector, then this will be true. But we want to remove the NA values. So we want this thing true when it's not NA and not when it is NA. That's why I put the exclamation mark there. In almost all programming languages, if you have a condition, if you have an if statement, if you put as an exclamation mark in the beginning, it will flip over what you have. So I think it's maybe working here as well. Yeah. So exclamation mark is .NA, NA is false. Exclamation mark, is.NA 300 is true because it is the opposite of what is NA gives back to us. So what will happen, and this is what you saw here with the numbers. So in the for loop, the element, the actual element will be printed in all cases and will be printed again if it will go into TMP vector. So if I'm running this and it's continuously not perfect yet, But if I'm running this, 4 was printed here, and then 4 was printed here as well. 9 was also printed in 2 places. 16 was printed in 2 places because they are all numbers. 25 was printed in 2 places. We have 2 NAs here, but not because NA was printed in 2 places. NA was only printed here. And then there is another NA, the next element in our vector, and it was printed only here again. So NA wasn't printed here, so it's working well, at least this part. And then 81 was printed again 2 times. So we have TMP vector with the numbers. We have the sum, we have the length, but somehow what we get back is wrong because we are getting back an NaN. Let's just print out the TMP vector here to see what is happening. Every time you change your function, you have to rerun the whole function, re-execute the whole function because it has to go into your environment again. So what we have to do is that we have to append our value into the vector, and then what it gives back as return value, we have to put into TMP vector again. And this is something I wanted to cover actually as well. So I think if I run it now, okay, we have a good average at the end now with 27. Okay, so the problem was that I haven't read the help page of vector merging well. In many programming languages, if you do just simply this, it will modify your TMP vector. In this case, it not modifies your TMP vector, it just puts together, and if you want that merged thing together, you have to assign it to another variable or the same. And this is again something what is a bit strange here, I think. It was very strange for me when I started programming, and I will just show it on the console with some more simple commands. So let's say that x is 5. Okay, so we have an x variable which is 5. You can say x is x plus 5. You cannot say this in maths. You cannot say that x equals to x plus 5. You can say this in R and in many programming languages. The reason is that because when you say equals, or when you use that arrow, and again, if I'm saying x equals to x plus 5, it's exactly the same, and it's executed. So this is what you shouldn't do in maths, because it's never equal. But in programming, when you see an equal sign, or when you see this arrow in R, it doesn't mean that the two sides has to be equal. It means that the right-hand side will be executed and evaluated first, and then the result will be put into x. So if here we say that x is 5, and here we say x is x plus 5, then actually what we are doing is 5 plus 5. So the new value of x will be 10. And then I said that x will be 10 plus 5, so x should be 15. And if you say here in my environment, x is actually 15 at the moment. Not 15, x is 15. The same thing happened here. I used TMP vector as a variable and I as another variable. merge them to one thing with the append function or command, and the result will be put into TMP vector, which was used here, but now it is updated. So that's how you can update a variable in programming languages. So I think my main function now it's much smarter than it was. So what it does, it creates this temporary vector, which will be an empty vector. I will just comment this here. So we are creating an empty vector to collect numbers from the input vector. Here, we are going through all the values of the input vector, which is x. We don't need this print anymore. It was just there for debugging purposes. And this one as well. Here we check if the actual value of our input vector is a number, is not an A. We put the value into our temporary array vector. Sorry. This print was only for debugging purposes, and this is the actual calculation mean, and this is where we give back the calculated mean. Is it black and white now for everyone, or is there any question? Because that, if you have any questions now, then we should. I can go through again. Okay, if not, then I will show you a slightly different way to do the same thing. Sorry if it's too boring just to do the same things again, but what I would like to show you is how you can use for loops, how you can use if statements. Oh, yes, okay. Rhiannon, are you?
Yeah, so I'm putting everything in as you've put. So everything was working up until we got to the last bit. And basically, I can't find anything that I've typed wrong. But it just keeps reprinting the same thing down in my console. It just isn't printing any numbers. It doesn't come up with any kind of...
Do you have this more than equal sign, or do you have this plus?
I have the plus sign.
Okay, so that's one. So it probably you executed something which wasn't closed. So usually if you initiate a for loop but you don't close it, then it will just stuck in.
Okay.
Just go into your console and hit escape.
Okay.
And you will get back your...
Okay, yeah, brilliant. Okay, I'll try again. That's great, thank you.
Okay, so that's what's happening usually in this case.
It's still just printing out the same thing again.
I think you are missing one of the closing curly brackets probably. So you just hit escape and leave it like this, and then you can just check it later.
Okay.
You can check this from my script as well later.
Yeah.
But what we will do now, we will copy this. No, I don't copy. I don't want to copy all the comments. So I will just say, make a my mean to it's the same x. So we are doing the same start, but instead of defining an empty vector to collect numbers, what we will sum up and we will divide by the length, we are just doing actually the summing inside the for cycle. So I will initiate a value which will be the sum. So shouldn't be the sum because it's a function. So we are using something else as a variable name. Let's just use s. So s will be 0 in the beginning, and I actually copy and paste here. And we also initiate a counter, which will be 0 as well. And here, instead of putting everything into the vector, what we are doing is we are adding our value to the sum. And I will tell you everything what I'm doing now. The CNT will be CNT plus 1. And y will be s divided by CNT, and we are returning y. So what is happening here is the same. So we have two variables, which is only visible again inside the function, s and CNT. We are going through all the values of our input vector with the for cycle. We are checking if there is NA, and if it's not an NA, what we are doing, I will use that value. I is always the actual value from the vector, and add it to s. Again, what you see here is not a mathematics, but it's a programming thing. So s will be a value which is 0 in the first for cycle. In the second for cycle, because our first value in our vector is 4, this line will look like s. Let s to be 0 plus 4. So s will be 4. The counter is 0. The counter will be 0 plus 1, so 1. So let me just put it here, because I think it will be, or I actually put it down here. First for cycle, s will be 0 plus 4. And CNT will be 0 plus 1. What is happening in the second cycle? I just write here that E will be equal to 4, of course, because this is our first element in our vector 1 array. In the second for cycle, E will, I will be 9. So what will happen here? S will be 4 plus 9. Why it is 4? Because it was modified to 4 in the previous cycle. So at the end of the first cycle, S will be 4, CNT will be 1. In the second for cycle, S is already 4, and I is getting the value of the second element of the array, which is 9. So we are adding up 4 plus 9. For the CNT, we are adding up 1 because it's already 1 from the first cycle, and adding 1 to it. in the third, fourth cycle, when I equals to 16, then S will be 4. So at the end of the second cycle, S is 4 plus 9, which is 13, plus 16, because that's our actual value. C and T was modified to 2. C and T will be 2 plus 1. So what I'm writing here is actually just writing these 2 lines, but with the numbers. Okay, the fourth cycle is, okay, I will write all of them, because then I can go back. So this was when I equals to 25. So let's modify S to, this is 29 plus 25, and C and T will be 3 plus 1. Okay, so this is what you have to do manually if you are doing the same kind of calculations what the programming language does for you. You have a bunch of numbers, you have to add them up, and then at the end you have to count how many numbers you added or summed up and divide by the number of numbers. What is happening in the fifth cycle? Actually, in the fifth cycle, it will not come in to this if, because the fifth element is an NA. So I will write it here. In the fifth for cycle, S remains 45, and C and T remains 4, because it's an NA value. In the sixth for cycle, the same. Because we don't go into the between the curly brackets of the if statement, so we won't change S and we won't change C and T. And in the seventh cycle, when I will be 81 and S will be 54 plus 81, and C and T will be 4 plus 1. So this is 135 divided by 5, and it's 27. So that's the average of the numbers, and we were calculating well. Is it clear what the for cycle does, and why do we use for cycle, and why do we a for loop, and why do we use the if statement, and how? If it's not, then please tell me. Thanks, Joe. So of course, if you run this, Command Enter, and then you are calling my mean to, my mean, hey, 2 here, and vector 1 here, then it will give back the 27 as the average or the mean. Of course, not everything is handled, I think, in this one. I'm just thinking about if you have any kind of string, but you shouldn't have any string in the vector. Yeah. Let's try to put a string, a character into vector 2. So if we look at vector 2 now, it has 2, 3, and 4 in it. So it has only 3 elements. But if I'm saying that vector 2, 4, so the 4th element should be hello. As you can see here, already the whole vector changed. So instead of it's a numeric, which like vector 1, it became a character vector. That's what we discussed last time, that in R, a vector can only contain one type of variable. So even if 2, 3, and 4 was a number before, just because we put in a character type variable, everything inside the vector is now transformed. So what is happening with this thing? Because actually none of them are NAs. So maybe we can just play with our I will just put this here with our average calculations. Let's say my mean 2, and let's try to calculate the average of vector 2. I guess it will give us some kind of error message, especially if I'm hitting Command Enter. Yes. So it went in to the if statement because none of the values are NAs. But as soon as you try to do something like this, you try to add 2 as a character to 0, it will drop you the error that one of them is a non-numeric argument, so it won't work. Let me show you one more thing with functions before we go and see some other very useful functions. So let's just make a plot. There are built-in plot functions in R, which we won't use too much because we will use ggplot, which is a much more useful and much much easier to use for making plots as well. But if you just say plot in R, it will work, and you say vector 1, vector 1. So we are giving 2 arguments here, and I hope it works. Yes, it works. So it will give you a very simple scatter plot where, of course, the x and y values are the same because we gave the x values in vector 1 and we gave the y values in vector 1 as well. If we make a vector 3 vector 1, so I'm now pumping all the values from vector 1 to vector 3, Command Enter, and I'm modifying the third value. For example, I'm saying vector 3, the third value should be 12. I think it was 9. It wasn't 9, it was 16. Okay, but it will be 12 now. Then if I'm replotting again with vector 3 here, something went wrong. I didn't run this. Yeah. Then as you see, the third dot on the scatter plot went down. Okay, so what we have here is a very simple function to plot x and y coordinates in a simple plot, scatter plot. So if you check the help for plot, it's huge because the built-in plot function can be used for many different things. But the two basic things what you give to a plot is always x and y. And if you don't say x equals to something or y equals to something, then it will handle the input arguments in their order. So if plot is accepting x in first place, then the vector you give, which is vector 1, will provide the x coordinates, and y is the second. Then in our case, vector 3 will provide the values for the y coordinates. But probably you can do this. I'm not sure, but I think you can do this. Yes, you can do. And here, what we did is that we named exactly that we want the x coordinates coming from vector 3 and y coordinates coming from vector 1. In many cases, your scripts will be much more clear and especially much more understandable if you use this kind of method when you are calling functions, and especially when you are calling plots. You have to write a little bit more in your script, but you will remember, okay, that I want to put these values as the x coordinate and that one as a y. And especially when you will do more complex plots with more things on it, with columns, or you will have some fitted line to your scatter plots, then it's much better to name what you really want to give as the x or y coordinates. Of course, you can swap these and it will be the same. I won't delete this from here, but if I'm saying it like this, it gives exactly the same plot. So in this case, it doesn't matter if the x is here or there, or the y is here or there, because we named them. But as we saw, this will give you a plot like this, or this will give you a plot like this. So it's different, just because in this case, we don't name which vector contains the x coordinates and which is the y coordinates. So as soon as you don't name them, the first one will be used for x and the second one will be used for y. Okay, so try to use this kind of version. Not every time you can do this. If you can, name the arguments. Of course, you don't have to do this thing when you are calling sum or when you are calling square root, because there is only one argument in square root. But as soon as you have more than one argument, it's better to name them. And this is the only point in R where x, where the equal sign and the arrow is different. So no, actually I will do it this one. As I said, the arrow And the equal sign is almost always interchangeable, almost always, but not here. Because what is happening here, we are not naming y and naming x, but we are pumping in. We are assigning the values from vector 1 to y, and y will be just given as a variable. So this won't be like this, as you can see. So if I run this, the dot, the third dot is up, is above the diagonal. If I run this, that third dot is below. So saying this is exactly the same as saying this, which is very confusing. But the only thing you have to learn is do not use arrow naming. I will just comment this whole line now because I don't want it to remain as a good solution, okay? I have a list of the useful functions. I'm not sure we should go through all of them, but what you will probably need many, many times is the length you will have. Okay, let's just put them here. Length. This will, as we already saw, give you the number of elements in the vector. I think it's also working for matrices or bigger things, but it's mostly you will use it for vectors. So if v is c1, 2, 3, then length v will be 3 because it has 3 elements. Okay, you will use this many times. I think the append is again a good one. It should be highlighted again here. So this is for merging vectors or slash vector plus single element. So if we have again a v vector here, and we have a single element 4, and we say that we should be append v se, so we are merging v with se, then we will be 1, 2, 3, 4. So just simply we just put this element here. You will do this many times. So as soon as you are starting parsing your outputs, you are just making a simple blast on your genes or protein of your interest, and the blast will output you 1000 lines, and you want to select only those IDs or those genes which are over some kind of threshold of identity or size, alignment size. Then what you will do is go through all the lines, what you got back from the blast search, and you will put into vector those IDs or those config IDs which should be interesting for you. And how you will do this, you will make an empty vector at the beginning, and you will append, you will put into those config identifiers which you think are over your particular threshold. It's a very useful command. The grep command is also very common, but I won't discuss it now. But I think, because I think the whole string handling is a separate meeting, is a topic of a separate meeting, especially because we are doing bioinformatics. We are working with text-based data a lot. So I think we have to give at least one complete meeting on how you can search, how you can parse, how you can go into text-based data and find what you want to find. If it's a gene, if it's a small protein sequence. Of course, finding something which is exactly there is easy. So if you just open a text file and choose a text editor search function, you can find that nucleotide or amino acid sequence easily. But if you want to find something which is ACG, but then it can be A or T, and then a C or A, and then ACG again, then it's not as easy. So for that, we have to learn how to use regular expression, which is a topic of one of the following meetings. And this is what grep can be used for. Range is a very, very useful command. Where's my chat? Ah, no, my chat window disappeared. Okay, it's here. Let's go to the help actually and see what the range does. I didn't want to do this. Return a vector. I'm just thinking what's the difference between range and column, but maybe there is no difference between. Ah, okay, no, sorry. No, this is actually giving you back the minimum and the maximum value as from, okay, this is also quite important if you have a bunch of numbers and you want to get back. Okay, that's actually the mathematical definition of range as well. Okay, I don't think we have so many very complicated vectors here, but maybe vector 1, what we can check. And we are again facing with the NA values, but luckily the range has this NA.rm argument as well. So NA.rm equals true. Then we will see that the minimum value of this vector is 4 and the maximum value is 81. So let me just put it here and I will define a vector which will be 1, 45, 6, and 4. And here you can see the range of V, which is 1 and 4. So it's the minimum and maximum value. If you just looking for the minimum or just the maximum value, it's very intuitive. It's min. I will put it here right next to the range because it's almost the same as what you can get out of the range command. So the min V is the minimum. What? Oh yeah, it's 1, yes. And the max value is 45. So you will use these 3 quite often as well. Oh yeah, this is a very, very, very good command as well. The sequence, not a DNA sequence, not a protein sequence, unluckily. But if you say, let's put let's b as a vector be a sequence of 1, 7, then it will be, as you can see here or here, it's a vector from 1 to 7. But you can also say it should be 1 to 8, but well, now let's just remain with 1 to 7. But the step is 2. So that means that we will be 1, 3, 5, and 7. So it will go up. It will go from 1 to 7 by a step of 2. One could practice with anything like this. If you want to make a series of numbers, for example, because you want to translate your DNA sequence to protein sequence. So you want 1, 4, 7 as the positions for the starts of the codons. So you have a sequence and you want the 3 characters from 1, and then 3 characters from 4, and 3 characters from 7, and so on. It's very easy to work with integers. It's not that easy to work with decimals. So if you do something like let's go 1 to 4 by a steps of 0.25. I think it is working, but you can have real problems with how the computer stores decimal numbers and how you define decimal numbers. I had this problem before. That's why I'm saying that if you show V now, it looks like it's nice 1, 1.25, 1.50, and so on. But maybe this 2.25 is not exactly 2.25. That's because decimal numbers are stored in a different way in the memory. And maybe it's 2.250000000000, and there's a 1 in the 12th place, just because it's stored in that way in the memory. So if you want to check if anything is equal to this one, maybe it won't be equal to that number you want to be equal to. So it's much better to always count with integers, but if you need decimals, just divide them within your for loop, for example. So what I say here is don't do this, but instead say that we should be a sequence from 1 to 13, and within your for loop, or just say v2 should be v divided by 4. It's not exactly the same. The two things are not exactly the same. This v2 and this v here is not exactly the same. Again, what you saw here, I took the advantage of vector-based programming languages. I didn't divide one number with 4. I divided a whole bunch of numbers, 13 numbers I divided by 4, but in one line. This cannot be done, as far as I know, in Python. This cannot be done in Perl, I'm sure, but you can do this in R, and also I think in MATLAB. So when you say that I want to divide my vector v by 4, then you are actually dividing all the numbers by 4. And we'll get back v2, which is numbers. Of course, it's not the same as it was here because I miscalculated it, but it's okay. It's actually the same if we go from 4 to 16. But again, as far as I remember, these two are not exactly the same. It's calculated differently. All right, next function. We will write here. The sort is always okay. Is a very good function. Now we can use our this one. The next one is sort. It's actually again in the name. So we are sorting. We was changed, and now it is sorted, and the smallest number is the first one, and the largest is the last one. You will do this again a lot of times, and I can imagine that the sort can be done in the reverse order. Yes, so if you look at the sort, then there is an optional argument decreasing, which is false in default. But if you say sort v and decreasing equals to true, then it will be sorted in the opposite direction. The same thing can be done with the reverse function. So if you have these two things here, and then you have reverse sort. Of course, you can always put in functions within functions as arguments. So the sort will give back the sorted vector, which will be then reversed by the rev function. So again, what you see here is exactly the same as we can do with the sort if we set with decreasing true. Of course, this will not change v because I haven't assigned the result. So if I print out v is remained the unsorted thing. Only if I say that v should be this thing, then it will be overwritten as well. But I don't want to write it now. Another thing with sort. Let's make something here. Oh, it's actually sorting in numeric. I'm trying to find that problem what we usually meet in Excel. So if you sort 1, 4, 6, and 11, 11 will go right after 1 because alphabetically 11 is before 4. But I think maybe the order. Oh, no, this is just giving back the order. That's not that important. I think this is the sort.int, maybe. So character string specifying the algorithm using not available for partial sorting. Let me check. I have to find this. I think the this is already strange here. No, 154. No, it's okay. Okay, I will try to find out for this just to avoid it. Oh yeah, some very common thing after just write each other round. Is it EI? Yeah. Okay, round 4.5. Of course, it's, hey, okay, it's rounding down. Okay, the rounding is doing the same as floor, I think. 4.5 should be 5. Well, this one is always rounding up. So if it's 4.1, it is also 5 because the ceiling is always rounding up. I don't know what it should be. Am I remember that 4.5 should be 5 to round it to 5, isn't it?
Yes, it should be.
Yeah, I think the same thing what we had, what I told before, that probably 4.5 is not stored as 4.5 within the brain of the computer. It's probably 4.4999999 something. Yeah, I think there are some warnings here, but these are again something what you will quite often use, these free comments. So this is the conventional rounding. This is rounding up. Even if it's 4.9, this will be 4. So this is rounding down. Right. All the conventional mathematic functions can be called in R. So for example, logarithm is there. If you say just simply log, it's the natural based logarithm. If you say log 10, what you can see here. So log, if you say log 10, it will give you a strange number. So this is the natural based logarithm of number 10. But if you say log 10, then it will give you 1. You can also use the log, the original log function, if you want to go any other base, not natural, not 10 base logarithm. So if you, for example, want to calculate the 2 base logarithm of 16, then I think you just say base is 2, and then it will be 4, as you can see down here in the console. So the 2 base logarithm of 16, of course, it's 4 because it's 2 on the 4th. So the sine, cosine is the same. I won't go. It's very. It's actually very simple. We already spoke about square root and sum up. You quite often have to use power. So you can just, I mean, you can always multiply numbers, of course, 2 times 2 is okay. I will just write it here. But if you want 2 on the 11th power, then you don't want to say 2 times 2 times 2 times 2 times 2 times 2 times blah, blah, blah. But you can say this. This is, again, almost the same in every programming languages. So this kind of rooftop is therefore putting numbers onto different powers. Also, you can, of course, use this for counting logarithms. So if you do it with 0.25, it will be 2. So it's the same as the 2. I don't know, 4 square root. I don't know, how do you say the square root with the number 4 up there? So it's actually the power of 1/4. This will be used quite often as well. I won't go into plots because I think the next meeting we will speak about plotting. Okay, I think this is enough for today. Is there any questions for functions?